Hi guys, and welcome to day 2 of our first unit of Algebra 2. So what we're going to look at today, we're going to transition away from the vocab and the graphs and really analyzing graphs and really going to turn back to just a paper, pencil, do the math, show the work, find your answer type method that a lot of Algebra 2 really is going to consist of. So today actually isn't going to be a ton of new stuff. There'll be a couple little new things for you, but a lot of review of some stuff from previous math classes, a lot of extra practice working on adding, subtracting, multiplying, and dividing fractions. So that'll be really good for you guys. Now, before we get started, I want to give you guys just some words of advice, some words of caution. Now, I know some of you are going to be doing this online and taking this class online and not in class, so I won't be able to harp on this as much. I want to tell you, I'm aware when you're taking this online or maybe even when you're taking it in class, you're going to have a lot of resources available to you that you wouldn't have in a normal class testing type environment. You'll be able to use a calculator, obviously, whenever you want because you're going to have one accessible there. I want to warn you guys to do as much of this, didn't mean to draw on that, to do as much of this as you can without a calculator. And that is going to be consistent for basically this entire class, guys. There will be a few days that we use calculators, and you'll know specifically because I'll actually bring a picture of the calculator into the video. But those days really are kind of few and far between. It's really, really essential, guys, that you do a lot of this work without a calculator, paper, pencil, to get the practice in. And the reason for that is because the skills that we're building right now, while they may seem simple or they may seem like you don't need to get a lot of practice in them, your future math classes are going to require you to recall these skills. Your future math classes are going to be dependent on just the basic skills you're learning now. So it's really important, guys, again, do as much of this as you can without a calculator. I know it's easy to get one out and just add these fractions together. You've got to get in the habit of doing without it because it's going to build those skills and make things easier for you in the long run. All right, now again, I'm probably going to bring that up multiple times, but again, the more of this you do on your own, the easier it's going to make your life down the road. I'll tell you guys, a lot of the calculus teachers have said what the kids who are struggling in calculus are struggling with is not the calculus concepts. They're struggling with the algebra because they just haven't had enough time to really dive in and get the practice in here. So again, take your time. Avoid the calculator, avoid any other aids that may help you do these problems faster, okay? The more you do this on your own, the easier it's going to make things for you later on. All right, so let's go in and actually do the math now. So notation-wise, what we need to understand when we see something like this, what that means is to take the f of x function and add it to the g of x function. So I'm going to have 1/3 x minus 2/5 plus x squared minus 5. All I have to do is combine like terms. I'm going to write my answer in what's called standard form. Really, that just means my exponents are going to go from biggest to smallest. So I would do x squared plus 1/3 x, and then I've got minus 2/5 minus 5. So in order to add those together, I need a common denominator. That common denominator is 5. Now I can subtract those two things and get a negative 27 over 5. All right, subtraction. So again, f minus g of x means f of x minus g of x. So 1/3 x minus 2/5. And I'm going to stop right here because I'll tell you guys, this is actually one of the most missed questions throughout the year. Not just now, but throughout the year. I'm taking the f of x function and subtracting g of x. If I write my answer, write my question like this, I'm going to get this wrong because that's not what this question is saying. This isn't saying I'm subtracting the g of x function. The only way to actually subtract that whole function is to put parentheses around it. And that's a really important step that gets forgotten about a lot. So be careful when you are subtracting a function that you subtract the entire function. All right, so I'm going to distribute that negative, and I'll go ahead and write my common denominators. So this is now going to become plus 5, but I'm going to write that with a common denominator of 25 over 5. And again, I'll write it in standard form. And I have my solution. All right, multiplication. You probably are familiar with foiling, okay? It's the same idea. Sometimes you'll have more terms, and it won't necessarily be foiling, but it's still the same process where you make sure you multiply everything times everything. So 1/3 x minus 2/5 times x squared minus 5. So 1/3 x times x cubed would be 1/3 x to the third. Then I would do minus 5/3 x minus 2/5 x squared, and then finally plus, that would be 10 over 5, which just reduces to 2. If I want to write this in standard form, I can just flip those two middle terms there. All right. Now division. Now this time, a little bit different. It's not f divided by g of x. It's f divided by g of 2. So that means in both the f of x function and the g of x function, I'm going to replace x with 2. And that makes this a little bit, it's going to give us a more definitive value. So 1/3 times 2 is 2/3. So that's 2/3 minus 2/5. I'm going to get a common denominator. That common denominator is going to be 15. So the left fraction is going to get multiplied by 5. So that's going to become 10 over 15. Right fraction gets multiplied by 3. Then I've got 2 squared minus 5, which is going to be -1. Go ahead and subtract those tops. That's going to give me 4 over 15 divided by -1, which is going to be a -4 over 15. All right, so now moving on. Same equations, just ran out of space here. We're going to do f of x. All that means is we're going to replace x in the f of x function with x. Whoops, I skipped a slide. Sorry about that. Thought I had my, there we go. Replace x with x plus h. So this is going to become 1/3 x plus h minus 2/5. I can go ahead and distribute and make that 1/3 x plus 1/3 h minus 2/5. Not much else I can do here at this point. All right, looking at this one. Same idea, f of x plus h, which I just found, so I'm going to go ahead and just write the same thing. And then I'm subtracting the entire f of x function. So I'm going to put it in parentheses. Be careful not to miss this. All right, again, be careful with those subtractions. So this gives me 1/3 x plus 1/3 h minus 2/5 minus 1/3 x plus 2/5. Well, then you'll notice that cancels, and I'm left with just 1/3 h. All right, so now we're going to look at the newer operation. So this is something called composition. So composition is really a function within another function. So the way composition works, you want to start with the insidemost part first. So the way I would read this first question here, I would read this as f of g of 2. So that's how I read it, f of g of 2. Now, we're going to start, like I said, with the insidemost part. So I'm going to start with g of 2. Well, g of 2 just means plug in 2 for x in the g of x function. So that would be 3 times 2 squared, which would be 3 times 4, which is 12. So 12 is going to replace g of 2, which means now I'm doing f of 12. F of 12 means replace x in the f of x function, which is going to be 12 plus 4. So my final answer here is 16. Now, I'll tell you guys, probably the biggest mistake with composition, at least to start, is that sometimes people think it's multiplication, okay? Again, the way this is read, this is f of g of 2. Notice it is not f times g of 2, okay? That's a different operation and a different question. To make it even more confusing, there's a different notation. So the notation that we just used, and the one we're going to use most often, is like this one over here. So the way that one works, again, the way we would read that is g of f of x, g of f of x. Well, this notation with that open circle also means composition. So that open circle doesn't mean multiplication. That open circle actually still means composition. All right, let's look at this next one. So g of f of 1. So we'll again start with the inside. F of 1, plug in 1 into the f of x function. So 1 plus 4 is 5. So now I'm evaluating g of 5. That means plug in 5 to the g of x function. 5 squared times 3, 25 times 3 is 75. Now you don't have to just do these with numbers. You can do these with actual functions. So again, f of g of x is how I read that. So f of g of x, the g of x function is 3x squared. That means 3x squared is going to replace x in the f of x function. If you want, you can write it this way. This is f of 3x squared. So very similar to what we just did with the x plus h. So f of 3x squared is going to just be 3x squared plus 4. All right, looking at the next one, g of f of x. So this is g of x plus 4. So x plus 4 replaces x in the g of x function. So this becomes 3 times x plus 4 squared. Now, we are going to go ahead and multiply this out because, again, another super common mistake. X plus 4 squared. This is not x squared plus 16. And that happens so much. You cannot, when you have a binomial squared like that, you're going to see this a lot this year. You cannot square the individual terms. You have to remember, x plus 4 squared means x plus 4 times x plus 4. And then you have to actually FOIL the whole thing out. So you get x squared plus 4x plus 4x plus 16. So if you just square the individual terms, you lose that middle, so you've got to be careful. Another way you can look at it, there's a little shortcut I always learned. Once we start factoring and looking at perfect square trinomials, you'll probably see this a little bit better. But I call it square double square. So to multiply x plus 4 squared, we square the first, we multiply and double, and we square the last. So it's square, it's double, and it's square. All right, so either way you work it out, x plus 4 squared becomes x squared plus 8x plus 16. Now I can distribute that 3 to get my final answer. All right, so now let's look at this next one. Really same concepts, kind of combining it all together, looking at some different functions. If you feel comfortable, pause the video, try these on your own. All right, so on this first one, f of g of negative 5. So I'm going to plug in negative 5 to the g of x function. So that's 4/5 times negative 5 plus 3. So that's going to be a negative 4 plus 3, which is negative 1. So now I'm evaluating f of negative 1. Plug in negative 1 to the f of x function. That becomes a negative 3/4 minus 2/3. Get a common denominator. So this is going to get multiplied by 4, multiplied by 3. And that's going to give me a negative 17 over 12. So again, I know the fractions are not fun, but it's really something we got to be comfortable with going forward. Okay, g of f of 6. So we'll plug in 6 to the f of x function. So that's going to be 18 over 4, which I can simplify to 9 over 2. Get a common denominator. So multiply this one by 3. Multiply this one by 2. Subtract them, and I get 23 over 6. So now I'm evaluating g of 23 over 6. So we're going to take that, we're going to plug it into the g of x function. So 4/5 times 23 over 6 plus 3. So when we multiply fractions, we're multiplying straight across the top and straight across the bottom. So 4 times 23 is going to give us 92 over 30. I'm going to go ahead and write this with a common denominator. That 3 can be rewritten as, well, actually I can reduce that 92 over 30. Let's reduce that to 92 over 30, divide both of those by 2. That's going to be 46 over 15. So now common denominator, that'll be 45 over 15. Add these together, I get my nice final answer of 91 over 15. All right, f of g of x. So this is going to be f of 4/5 x plus 3. So this becomes 3/4, 4/5 x plus 3 minus 2/3. So when I multiply, distribute that 3/4, those 4s will cancel. That'll give me 3/5 x plus 9 over 4 minus 2/3. Again, I'm going to need a common denominator to combine those together. That common denominator is going to be 12. So that becomes 27 over 12, 8 over 12. And that's going to give me 3/5 x plus 19 over 12. All right, so now we're going to go ahead and do g of f of x. So this is going to be g of 3/4 x minus 2/3. So I'm going to replace x in the g of x function. So 4/5, 3/4 x minus 2/3 plus 3. We can distribute that 4/5. That's going to give me 3/5 x minus 8 over 15. Need to get a common denominator, so that 3 is going to get multiplied by 15 top and bottom. So that gives me 3/5 x plus 45 minus 8, which is 37 over 15. All right, g of x. So again, you don't have to use a different function. I can actually put a function within itself. So I'm going to do g of 4/5 x plus 3. So this becomes 4/5 x plus 3 plus 3. I replaced the x with 4/5 x plus 3. All right, so let's go ahead and distribute. So that's going to give me 16 over 25x plus 12 over 5 plus 3 over 5. Oh, not 3 over 5, sorry. I'm getting ahead of myself. Plus 3. We're going to get a common denominator, so I'm going to rewrite that as 15 over 5. So that's 16 over 25x plus 27 over 5. And then finally, we've got f of x plus h minus f of x. So again, very similar to what we did previously. We're going to do 3/4, replace x with x plus h, minus 2/3. And then I'm going to subtract the entire f of x function. I'm going to put it in parentheses. So now I have 3/4 x plus 3/4 h minus 2/3 minus 3/4 x plus 2/3. 2/3 will cancel, 3/4 x will cancel, and I'm left with 3 over 4 h. All right, so for these last couple, we're going to step away from the heavy algebra. Okay, so it'll be a lot easier on the numbers, but really just understanding kind of the process of what we're doing here. So we're going to evaluate these by using this table. So the first one on there is f plus g of 1. So remember, f plus g of 1 means f of 1 plus g of 1. Well, looking at my table, f of 1 is 3. G of 1 is 4. So 3 plus 4 is 7. And that's it. Pretty simple if we can understand the notation and how to read the table. F minus g of 3 means f of 3 minus g of 3. 0 minus 6 is negative 6. F times g of 2. So f of 2 times g of 2. So 2 times negative 3, negative 6. G of f of 3. So f of 3 is 0. G of 0 then is what I'm now evaluating. Okay, g of 0, when x is 0, g of x is 7. Now remember, this is the weird notation for composition. This means f of g of 1. So we'll start with the inside, g of 1. G of 1 is 4. Now I'm evaluating f of 4, and f of 4 is 2. All right, f of 1. So start with f of 1. F of 1 is 3. F of 3 is 0. Again, if you feel comfortable, guys, pause the video, try these last couple on your own. All right, g of 4 is 0. F of 0 is 5. And then next one, g of 4. So g of 4 is 0. G of 0, when x is 0, g is 7. And then the last one, very similar idea, but instead of a table, we're just looking at a graph. But it's still, notation is the same concept here. So f of g of 0. So g of 0 on the g of x function, when x is 0, the point on that graph has a y value of 2. So g of 0 is 2. So we're going to replace that with 2. So now I'm evaluating f of 2. That means I'm going to use the f of x function, and I'm going to look when x is 2, what is my y value? And I get 9. All right, looking at the next one, f of 0. Okay, when x is 0, on the f of x equation, I get 1. G of 1. When x is 1, on the g of x equation, I get -1. Again, if you feel comfortable, pause the video, try these last ones on your own. All right, f of 0 is 1. F of 1 is 6. G of 4, so g of x equation, when x is 4, y value is 2. F of 2 is 9. F plus g of 3 means f of 3 plus g of 3. So when x is 3 on the f of x equation, I get 10. G of 3 is -1, and I end up with 9. All right, and then looking at the last one, f times g of 2. So again, f of 2 is 9. G of 2 is -2. All right, so that is it for operations and composition. Composition is actually going to come back in our next class, so hopefully you're a little bit comfortable with it, but that is it for today.